Welcome back, algebra students, to 6.5 Linear Inequalities. Today we're going to be talking about what is a linear inequality. Just as the name suggests, linear, we're talking about straight lines. So if you're thinking of y equals mx plus b or anything in x and y coordinate plane, that's what we're talking about. And inequality, obviously talking about less than, greater than. So a linear inequality is a linear relationship expressed with an inequality. And words don't really do it a lot of justice. It makes a lot more sense if we get into examples. So here in this example, we're talking about, so the example is x plus y is greater than 3, okay? So what values of x and y make this true? So now we need to come up with examples, numbers of x that make this true, and values of y. And you have to use them together, okay? So I was going to use red, but I'm going to change it to green. So green is going to be like my first combination. So let's say I picked 2 for x. What could I pick for y to make that true? So 2 plus something is bigger than 3. I could make y also 2. Okay, and they don't always have to be equal to each other. So my second round I use purple. So I could make x equal to 5. And I could make y equal to 10. 15 is bigger than 3. And to show that, we do 5 plus 10 is bigger than 3. Check. That's true. Okay. Now I could use negatives if I wanted to. I could say, let me use different color than, let's use orange. I could say x could be -1. So if that's -1, then y could be something else. Y could be 14. -1 plus 14, is that bigger than 3? Yes, it is. Okay. So there's a lot of different possibilities. So the answer can be written as these answers that I put here, the green and the purple and the orange. What can they be written as? An ordered pair. An ordered pair. Okay? So 2, 2 could be one of the ordered pairs, and then let me do one more. -1, comma 14 is another ordered pair. All right, how many points make this true? How many did we come up with? Well, if -1 plus 14 is true, then what about -1 plus 15, -1 plus 16, -1 plus 18, 20, 100, 150, 1,000. Okay, there are an infinite number of points. That is a sloppy infinite sign. Let me try that again. There is an infinite number of points that make that true. Okay. Now, steps to graphing. I highly recommend the option number 1. I kind of put optional underneath it, but in my opinion, it's best if you convert to y equals mx plus b form. Okay? Y equals mx plus b form. That makes it way easier. So basically, you're going to solve for y. You're going to get the y by itself. Step 2, you're going to graph. Step 3, you're going to make your boundary line. Oh, and step 4, you're going to solve for y again, and then you're going to shade. Okay? So the reason why we need to shade, as I'll show you in a second, is to express the infinite number of ordered pairs that make that true. Okay? So the first thing we're going to do is we're going to take the example that we've been given. X plus y is bigger than 3. Now, I think it's best to solve for y, get y by itself. So I'm going to subtract x from both sides. And I get y is greater than 3 minus x. Okay? Now I need to graph this. As a quick summary of graphing slope-intercept form, y equals mx plus b. B is your y-intercept. M is your slope. Okay? You start by graphing the y-intercept. So in this case, it's 3. I'm going to use purple. Graph it on 3. And now I'm going to use my slope. It's the number in front of x. It doesn't look like there's a number, but there is. Our number is -1. So I'm going to go down 1 to the right 1, down 1 to the right 1. Okay, and when I'm doing linear inequalities, I like to make a lot of points. Okay, and I don't connect the line yet. That's very important. Okay, you don't connect the line. You don't go ahead and draw this line and connect them. And there's a reason for that. So step 2, I graphed it. Check. I converted. Check. Boundary line. Okay, so the boundary line. Let's test this point. So let me look at this point. The first point was our y-intercept, 0, 3. So if I were to pick, let's use pink, I suppose. If I were to pick 0 for x plus 3 for y, is that bigger than 3? So is 3 bigger than 3? And that's no. So I cannot include that point. Well, how do you graph a line and not include that point? Unless you have an invisible pencil, it doesn't work. So to account for that, what we do in math is we draw a dotted line to show that we don't include any of those values that are on the line. Okay? Now, the values that we talked about, we did come up with true values, just not on the line. We don't want to include those values. And we draw our arrows because it continues infinitely in both directions. Okay? So anytime we have a less than or a greater than sign, let me make this in red for emphasis. Style. Red. We are going to use a dotted line like this. Anytime it's less than or equal to or greater than or equal to, we can include those points, so it's going to be a straight, solid line. Okay? So make sure you guys write this down. This is important to help you graph your boundary line. We're going to solve for y if we haven't already done so. I mean, technically you can graph without solving for y, but the shading part is why it makes it especially useful to solve for y. So we've already solved for y. We have y is greater than 3 minus x. I'm going to change this to purple just so the other note keeps the emphasis. So now I'm going to shade. So I'm going to shade all the values that made it true. Now we came up with 3 over here. We came up with 2, 2. That was a point right here. We came up with 5, 10. 5, 10. That's somewhere, let's just say up there. And we came with -1, 14. So somewhere over here. I know it's off the grid. But we're talking about here, 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 anywhere over here. But what about 0, 0? Can we put 0, 0 in there? Is 0, let me use light green, 0 plus 0, is that bigger than 3? It is not. So we can't include this point, we can't include there, there, there. As it turns out, it's all the places that are above the line. All the places that are above the line. Okay? So if it's y is greater than, you are going to graph above. And I like to think of this as shade. You're going to shade above. If it's y is less than, you are going to shade below the line. Some people get confused on where the shading is. Let me change to my shading color here. So I'm going to use, might as well use purple to shade. So if you're ever confused on where to shade, just pick any point and then pick a spot above it. That's where you shade. Any point, like down here, shade above it, right there. Okay? Some people get confused on where above is, especially when you get steep lines, but just pick any point, pick above the line, and then shade, and then that is what your graph should look like. I know I'm doing a super terrific job, but I hope you guys get the idea of what this looks like. So now I'm including all the possible values that satisfy that equation. And that is your step-by-step process. I'm going to end this video now. I think this is a good chunk to digest, but be sure to return back so we can go over a couple examples right after these messages.